Functions?
Yeah, totally!
Woo!
Alright, that's done.
Alright.
Alright. So, before we get into functions, you need to know what the domain is.
And the range.
Domain is all of the input values.
The range is all of the output values.
As you can see, just like a machine, think about a soda machine. You put something in, and then something happens, and you get something specific out.
So when we're talking about functions, a function is a specific type of equation where all of the elements in the domain map to exactly one point in the range.
So what does that mean in English? It means that for every input, there is exactly one output. So if you notice, it doesn't matter if they have the same output as long as they're different inputs.
So we can figure out if something is a function based on its function map. So we need to make sure that every input maps to exactly one output.
What do you think about the first one? Very good! This one is a function because none of the input values have a repeating output value.
How about the second one?
Your whole block.
Great!
This one is not a function because you can see that the input value 5 maps to 2 different output values.
Great job! What about these relations, these sets of points? What do you think? Great job! If we look at this one, all of the input values are different. None of them map to the same output.
How about this set of points?
It's only showing your arms. None of your body, it's just your arms.
Great job! This one is not a function because the input value -2 repeats and has 2 different output values.
What about on a graph? Let's think. If every input value is x, if it has no repeating output values, that means none of them will be on a vertical line that could be drawn anywhere on the graph. What about this first one? Great job! This first one is a function. As we can see, I can draw vertical lines anywhere on this graph, and each vertical line will pass through at only one point.
What about this second one? Hooray! This one is not a function because if I follow the same vertical line test, I can draw lines through the function and notice that at one x value, I'm touching 2 different y values.
Wow, this is a really crazy one. Great, so if you look, this is called a piecewise function. We will get to this later. You will see that this is an open point. So all of the vertical lines that I draw here will only touch at one point. Here is where it gets a little confusing. This open point means that it is not included in the output. So this is not a point, even though it looks like one, it's an open point. Same goes for this. This is open, so that value is not included. If we were to look at those input values 1, the output value 3 is not included in that set.
So, what do you think if we had an equation and we asked you to determine if it was a function or not? What could you do? Well, sometimes you just have to think about it. You have to think about the different values of the domain that can be put into the function to figure out what that range might look like.
So here's an example. I'm thinking about all of the input values here. You raise a very good point. What if I plug in 4? The square root of 4 could be either positive 2 or negative 2. This means that in the domain, the element 4 would map to 2 different output values. Womp womp.
That makes it not a function.
This would not be a function.
Good. Just one more thing we want to talk to you about. This crazy thing called function notation. We talked about it before, that this f of x just means your output. What you get after you plug in a specific domain, what that output value is. So, sometimes we'll see functions set up like this. F of x equals 3x minus 2, and then this other one, g of x equals x squared plus 5.
So, a few misconceptions is some people think that this might say g times x. This is just naming this rule. This is naming the function g. We just call g of x the output, as Ms. Neubauer said.
So we can ask you to evaluate these functions at specific x values. So what this piece means, f of 3, it means take this function 3 and evaluate it, find the output, if your input value is 3. So we could write this as 3 times this 3, your input value, minus 2. That would be what f of 3 equals. Then we can solve it. 3 times 3 is 9. 9 minus 2 is 7. So we know that f of 3 equals 7.
Similarly, we have to substitute x equals -1 into g and figure out what the corresponding output value would be for -1. So we would substitute in -1 and get -1 squared plus 5. -1 squared would be 1, plus 5 would be 6, telling us that g of -1 equals 6. Now this is all fine and dandy, but if we look back up here at our original expression that we need to evaluate for, we need to substitute these numbers in. We've learned that f of 3 equals 7, and we've learned that g of -1 equals 6. Just as if this was a random variable such as a, and this was a random variable such as b, we can substitute in a value for it that corresponds with the input. Now we just need to simplify this very lovely expression, and if we use our order of operations, we'll first need to simplify multiplication to get 12, and then -5.
Please put the negative. It's very different from positive 5.
Absolutely.
Well, that's all we have. Good luck on your homework sheet, and we'll see you on Monday.
Woo!